Assalamualaikum to Dr. Nurul Ain Izzati. We are students from BFC 25103, Engineering Mathematics. We will present our group project. We are from Group 5. This is our team members from Group 3. First, Hafiza, CF220185. Second, Rishan, CF220248. Third, Nurul Izzati, CF220242. And fourth, me, Muhammad Rafiq Shemir, CF220160. And the last one is Fatin Nabila, CF220216. Okay, for our project, the title is Application of Engineering Mathematics in Civil Engineering Area.
Next, I will continue for the table of content. In this presentation, include the introduction, objective, problem statement, methodology, literature review, calculation, discussion, and also conclusion.
In Malaysia, Johor State has been one of the states that has consistently experienced flooding over the last few decades. One of these elements that contributes to the floods in the state of Johor is thought to be the tide collision in combination with the extraordinary rainfall distribution, where certain places receive a rainfall distribution equivalent to the rain for several months. The objective is to propose an appropriate drainage system that could successfully lessen the heavy flow. Then, to decide which drain system will work best for the Taman University Parit Raja drainage system in terms of kind of size. 3 is examine the drainage system at Taman University Parit Raja and the flow rate through the plain drainage system. Our problem statement is the drainage system was not correctly designed to reduce floods and heavy from overspill to the road. Then, the stormwater drainage system must be carefully designed since the size of the flow channel is inappropriate for the area. The project instructions specify the study location, which is at Taman University Parit Raja, Batu Pahat. There was an existing drainage system near the main road and the major drainage system, which comprised main drains, also known as interceptor drains, and which supplies a significant percentage of the city, receives water from these little drains.
Hi, Assalamualaikum. My name is Nur Hafiza binti Muhammad Basri, CF220185. I want to explain about methodology. A methodology is a group of practice used in a particular activity or field of study. In this case, we will deal with three variables integration, known as triple integrals. Basically, there are three coordinate systems which we need to discuss, namely in Cartesian, cylindrical, and spherical coordinate. We can obtain volume of solid G by using triple integrals in Cartesian coordinate x, y, z. So this is the equation of triple integrals. In this project, we choose cylinder shape as our problem. So the figure shows the cylinder in 3D graph and also the equation of the cylinder. We notice that the variable of x, y, and z in the function are always quadratic. In example, power of 2. When only two of the variables exist in the equation, it is a cylinder. So we deal with three types of cylinder, the equation of three types, and the axis that lay also state in the slide.
Next, for the literature review, the high intensity of rainfall is primary causes of flash flood, irregular constriction of the earth drain flow channel, the pace at which drain filters to the study area, expensive allowed development discharge, and also the terrain of the research area.
As for the calculation part, as we know, we already got our water flow, which is 0.11 meter cube per second. From the water flow formula, which is V over T, time is 1 hour, which is 3600 seconds. So from that, our volume is 396 meter cube. As to find the volume of the cylinder, so we are using triple integration method. First, we determine the limit for x, z, and y. And we use the triple integration method by using 1 dx as the first integral, and we followed by y, and we will get the area is 38.7 meter square, which is in negative, but we can ignore because the area will always be positive. Then the calculation is followed by third integration of the negative 38.07, and we will get negative 152.28 unit cube. As we know, volume is always positive, so we can ignore the negative sign. And therefore, the volume we get is way lesser than the volume that we should get. Therefore, after a several try, we determine y1 equals to 0 and y2 equals to 12. And the volume we get is 456.84 meter cube, which is higher than 396 meter cube. Therefore, the dimension of our cylinder going to be 12 meter length, and the diameter will be 10 meter. Thank you.
Next discussion. The problem that came from the flood has caused to us to do research related to the cause of how the area can flood, and we found that the length of the existing drain channel is too short and it will cause the water to press through the be able to move well and easily get blocked. With the calculation we provided, we found that the drain's length needs to be extended further to prevent this from happening again. By using the triple integral method, we can calculate the volume of the water that can fully flow in the drain by following previous research done from UTHM student. We found that the volume of the existing drain is 396 meter cube for the drain with a diameter of 10 meter and a length of 4 meter. We have calculated and evaluate the size of the drain that we recommend, which is the drain with a diameter of 10 meters and a length of 12 meter has been calculated, and we found that the volume of this drain is 416.84 meter cube. Okay, for the conclusion, we found that using triple integral is the easiest way to get the volume of the range and it more useful to application it in our daily life. The triple integral is the technique or we call it solution for us to find the volume of the drainage and other things. So that's all from us. Thank you.